absolute value. This is day 3 of a 4-day lesson. Essential question: what is different about solving an equation with absolute value bars? So far this year in chapter 2, we've solved equations that did not have absolute value bars, and we've solved absolute value expressions, so no equal sign. This is going to be the first time we're going to combine together equations and absolute value signs. All right, our first question is, if the absolute value of x equals 7, what could x be equal to? So we need to think about what is absolute value. We defined that in the first day of 2-5, and it was the distance from 0 on a number line. So if you think about a number line, if we've got 0 in the middle, and then I'll make up to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8, 9, 10. They are asking what numbers are 7 away from 7 away from 0. So if I go 1, 2, 3, 4, 5, 6, 7, this is 1, 2, 3, 4, 5, 6, 7 away from 0. But I can also go to the left. 1, 2, 3, 4, 5, 6, 7. So both negative 7 and 7 are 7 units away from 0 on a number line. Now remember, distance cannot be negative. So we know that there are 2 possibilities, because you can have the negative possibility and in this case a positive possibility. Now that's not always going to be true, but the important part to think about is that there will be 2 solutions, which you'll always see in a second. Because we can always have the negative and then the positive. All right, if the absolute value of x plus 1 equals 5, what could x be equal to? Well, we've got to think about the fact that we want this to either total 5 or negative 5, because if we take the absolute value of either of those, we would get positive 5. So if I'm trying to figure out what just x is, we have to think about what number plus 1 would give me 5. Well, I know that 4 would give me 5, because 4 plus 1 equals 5. Absolute value of 5 is 5. Now, what other possibility would give us negative 5? What number plus 1 is negative 5? Well, that would be negative 6 plus 1 gives me negative 5, which has an absolute value of 5. So my 2 solutions are 4 and negative 6. So just like the top example, I ended up with 2 solutions. On this one, I also end up with 2 solutions. That's going to be the pattern for the lesson. There's always going to be 2 solutions to every absolute value equation. All right, now we're going to get a little bit more complicated equation. So this one is the absolute value of 4t minus 8 equals 20. One thing we use to help you remember that there's going to be 2 solutions is that if you think of there's 2 absolute value bars, then there's going to be 2 solutions. Now you'll notice on the right here where I have my equation, I have an arrow branching off that says case 1 and case 2. This is how we're always going to make sure we get both of our answers. Now on those last 2, we could easily do them in our heads. But now when you've got an equation like this, it gets a little more complicated. We're going to set up 2 equations that will give us both of the solutions. For case 1, we drop the absolute value bars and we just write the equation exactly how it is. So nothing changes except we drop the absolute value bars. In case 2, this is the hard one to remember. This time we keep the 4t minus 8 how it is, but we make the 20 negative. This will end up giving us both of the correct solutions for t, and I'll show you why in a second. So if I draw my train tracks and solve this, add 8 to both sides, 4t equals 28. Break up my couple, so divide both sides by 4. We're solving this equation just the same way that we did all chapter long. So one of my solutions is 7. Let's see if that works. Is 4 times 7 minus 8, 20? Yep, it is. So that one works. All right, let's try our case 2. Add 8 to both sides. That's my third wheel. 4t equals negative 12. Divide by 4. And I end up with t equals negative 3. Let's see if that solution works. 4 times negative 3 would be negative 12. Negative 12 and a negative 8 make it negative 20, which we know the absolute value of negative 20 is 20. So now I'm going to graph these solutions on my number line. I'll put my 0 somewhere in the middle here. Positive 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there's one of my solutions. And my other solution was negative 3. 1, 2, 3. All right, we've got another one just like that. All right, this time we have 3t minus 1 equals 11. All right, so we said case 1, we're going to keep it the same, just drop the absolute value bars. 3t minus 1 equals 11. Think to yourself, what is changing in case 2? The 11 becomes negative. If I solve both of these equations, add 1, that's my third wheel. 3t equals 12, break up my couple. I end up with t equals 4. Let's see if that works. 3 times 4 is 12. 12 minus 1 is 11. That one works. Case 2, add 1 to both sides. 3t equals 12. Divide by 3. Divide by 3. T equals 4. Now you'll notice on this one, they're both the same solution. Which, I made a mistake. There's why I caught my mistake. Negative 11 and 1 will make negative 10. Negative 10 over 3, that one we're going to get a fraction, but that's okay. It would be, what, negative 3 point, we'll say, negative 3.1 roughly. Okay, so if I graph my 0, I've got 1, 2, 3, 4, positive 4, and I've got negative 3.1. All right, third one, 6y minus 7 equals negative 1. Now I want you to stop and look at this equation for a second and see if you can figure out what is different about it. If you notice that this 1 is negative, you're correct. There is a problem with that. If we think about absolute value, if I take the absolute value of something, my answer is always going to be positive. And that's because distance cannot be negative. So no matter what ends up in my absolute value bar here for y, if I take the absolute value of that, I can never get a negative 1 because I can never get a negative number. The answer for this one is no solution. There are no y values that I could plug in here, get negative 1, and then have that still be equal to negative 1 after I take the absolute value of it. All you have to do for that one is write down no solution and move on. All right, click and drag. We're going to drag the equations into either the two solution circle or the no solution circle. Since this one equals negative 11, it's no solution. Since this one equals positive 3, there's two solutions. Since this one equals 1, there's two solutions. Since this one equals negative 1, there's no solutions. Since this one equals positive 14, there's two solutions. Negative 8 would be no solutions. Negative 10 would be no solutions. positive 5 would be 2 solutions. The homework for this lesson is page 105 through 106, numbers 4 through 9, 22 through 24.